Hello my dear students, good afternoon. Now we will discuss about one of the important spectrum, that is hydrogen spectrum. Okay, actually this is an example of electromagnetic spectrum. Actually due to absorption of some energy or some radiation, okay, they form some series of spectral lines. Okay, those spectral lines was first observed in hydrogen dissociation by Balmer. Who is that scientist? Balmer. So actually first observed this scientist Balmer series we have to understand first. Actually what this Balmer did we have to understand clearly. So in line spectrum, actually how that line spectrum formed and how those spectral lines are present we will see. So he was taken a discharge tube, and here you have a cathode and here you have anode like that, and H2 gas, actually H single bond H, when it was dissociated, when it was hesitated in a discharge tube by sending high voltage current, this converted into hydrogen atoms. Those hydrogen atoms further convert into hydrogen ions, which we call protons. Okay, and along with that, electrons. So those electrons which was ejected, they have more energy because these electrons formed due to absorption of some heat or some energy. So these electrons have very much high energy. Okay, so those electrons will go to higher energy levels, and from higher energy levels and they will come down again. That is called by emission of energy. Those electrons will come down from higher energy level to lower energy level. While coming from higher energy level to lower energy level, they form some spectral lines. Those spectral lines was first observed by this scientist Balmer. What I said understood, sir, here? So hydrogen gas was taken in a discharge tube, and it was hesitated in this discharge tube, and hydrogen molecules will dissociate into hydrogen atoms first, and further they convert into H plus and 2 electrons. And those electrons will go to higher energy levels. Electrons are revolving in circular orbits. I was given in Rutherford atomic model, and in previous also in quantum numbers. There also I was given. So here nucleus, and here these are the orbits. We call K, L, M and N like that. And N value, these orbits represent with N value. For the new students I am saying. So K, L, M, and these orbits represent with the small n. N takes the values 1 and 2, 3, 4 like this. If n is equals to 1, K shell, n is equals to 2, L shell, n is equals to 3, M shell, n is equals to 4, N shell like that. As you are going away from the nucleus, energy increases. That means N shell has more energy, K shell has less energy. So ultimate ground state is K shell. This is called ground state actually for every atom. So least energetic is K shell, that is called ground state actually. In general, ground state. These are all called excited state. So when electron ejected, that has more energy, and those electrons will go to higher energy level, and afterwards they will come down and they form some spectral lines like this. These lines, spectral lines observed, and those series of spectral lines we call hydrogen spectrum. Okay, and this spectrum first observed by Balmer. Understanding? Arrangement of all these spectral lines in the increasing order of wavelength or decreasing order of frequency in hydrogen spectrum we will see now. Understand? But before that, first we will discuss about this Balmer series. Okay, so what Balmer observed? Balmer observed these kind of spectral lines in visible region. Okay, what region is very important. In visible region, he was observed these spectral lines. So last and final time I'm telling, hydrogen molecules dissociating into hydrogen atoms converted to hydrogen ions and electrons. Electrons will jump to higher energy levels because they are absorbing energy, because the electrons ejected means they are more free. More free means they have more velocity. They will go to higher energy level. Okay, electron if it is in higher level, that won't be in higher level always, that will come down slowly. While coming down from higher energy level to ground level, they are forming some line spectrums. Understanding? They are forming some spectral lines. Those spectral lines was first observed by Balmer in visible region. And how the electron jumping taking place, he was explained. He said, Balmer said, electron is jumping from higher energy level to second level. Second level means what? This level, he said. What he said? Balmer what said? Electron is jumping from higher energy level to second level in visible region. Sir, why second level? Why not third level? Why not fourth level? And why not electron not coming to first level? Maybe coming. In visible region, you cannot see those spectral lines, maybe. Understanding? Yes, that is correct only. Those later on, Mr. Lyman, bracket, Fund, those was explained. Electron transition means electron jumping from higher energy level to lower energy level. Not only from higher to second, higher to first, higher to third, these all happening, but different electromagnetic regions. Understanding? So those all things was explained in this hydrogen spectrum. Understanding? So invisible region, what he observed as excited electron is coming down. Excited electron coming down to what level? Second level. He observed the spectral lines like this as H alpha, H beta, H gamma and H delta like this. So this one is called ground level. So ground level means you said n is equals to 1, no sir. In general 1, but for Balmer series, electron coming to lower energy level. What is the lower energy level for Balmer? N is equals to 2. Because in visible region, those spectral lines only he observed as electron coming from higher energy level to second level. Understood sir everyone? So ground level to second level, sorry, higher energy level to ground level. Ground level means what? Second level he observed. So ground level means here what? N is equals to 2. N1 here. N1 means lower energy level. N1 is 2. N1 is 2. And N1 is 2. Observe. And here N2 means higher energy level. It's 3. 3 to 2 H alpha. N2. 4 to 2 H beta. N2. 5 to 2. Okay. H. Yes. Gamma. H gamma. And this is delta. Okay. H delta. 6 to 2 like that. Sir, understanding? As electron jumping from higher energy level to second level he observed. So he kept some those spectral lines as H alpha, H beta, H gamma, H delta like that. Okay. What Balmer was observed? Electron, first exciting electron first. Those excited electron, forget about that. Now, while coming down, they are forming spectral lines. Remember that one only enough. What observed? The excited electron is jumping from higher energy level to second level. He observed Balmer. Understand what Balmer observed? Okay, Balmer observed as electron jumping from. Okay, electron jumping from higher energy level to second level. What is the second level means? N is equals to 2. N is equals to 2 means what shell? L shell. Electron is revolving certain orbits, no? Those are called shells or orbits, okay? So those are very important. So what is H alpha line? According to Balmer, H alpha line means N1 is 2 and N2 is 3. H beta means what line? Electron jumping from N2 is 4, N1 is 2. So Balmer means N1 fix. Balmer means what is the N1 value? 2. That's it. Higher level greater than 2. 3, 4, 5 can be up to infinity. Higher level means we cannot say. Higher level they will give in numerical. You have no need to worry. But Balmer series means N1 is fixed. What is N1 value? 2 like that. And H beta. H gamma. N1 means 2 and N2 means 5 like that. Like the delta also. Understanding? What is H alpha line? Which was given by Balmer. If electron jumps from third level to second level, H alpha line. Fourth level to second level, H beta. Fifth level to second level, that is H alpha beta gamma. H delta means, if you want I will write. H delta means N1 is 2 and N2 is 6. Electron jumps from 6 to 2, that is H delta line. Okay. What is N1 here? Ground level. Ground level means lower energy level. Lower energy level. What is N2? N2 means higher energy level. Lower energy level to higher energy level. Understood, sir? So these are very, very important. So what Balmer observed? As electron jumping from higher energy level to second level. Okay, and those he represented, those means those spectral lines he was represented with H alpha, H beta, H gamma, H delta like that. So N1 is a ground level. Ground level for Balmer means 2. Remember this one. In general, first I told you. Okay, if they said in general means N1 value 1 we have to take. Okay. So next Balmer what given we have to discuss. In Balmer series, what is the ground level we discussed and what is the higher level we discussed. Now we have to discuss how to calculate wavelength and wave number and frequency energy of our spectral lines. Okay. So as electron jumping from higher level to lower level, that is forming a spectral line. Spectral line means that is traveling like this. Actually spectral lines we represent like this, coming like that. But that has a wave number. Wave number means number of waves. That has an amplitude, that has a wavelength, that has a frequency. So for a spectral line, what is a wave number? How to calculate? We have to see now. Okay. So Balmer was given one formula, mathematical formula to calculate this wave number. Okay, wave number nu bar. Wave number is reciprocal to wavelength or not? Yes, wave number is equals to 1 by lambda is equals to RH into 1 by N1 square minus 1 by N2 square into Z square. This formula was given to calculate wave number of a spectral line. What is nu bar here? Nu bar is wave number of spectral line. Means how many spectral lines are forming in particular 1 centimeter length, unit length. That is called wave number or not? What is wave number definition? The number of waves present in unit length. So in unit length, how many waves are present? So lambda means same wavelength. Okay. So if lambda asking, 1 by lambda is equals to this formula we have to take. 1 by 1 I will tell you, but remember this formula. This formula is very important to calculate wave number. Nu bar or wavelength u bar is equals to 1 by lambda or is equal to RH into 1 by n1 square minus 1 by n2 square into z square. And here I was given very clearly n1 means lower energy level, lower energy level. N2 means what? Higher energy level. N2 means, okay. Z means atomic number. Z means what? Atomic number. And most important thing, this is RH. RH is called Rydberg's constant. Rydberg's constant, very important. Okay, so what is Rydberg constant? Like Planck constant, we remembering one value, no? 6.6 into 10 power minus 34 joules. Like that, this Rydberg value also we have to remember. Okay, so what is the Rydberg constant value? It is 109,677 centimeter inverse actually. Okay, so for solving numeric, this is RH exact value. Experimentally, those scientists was given by using this energy formula actually, that we can understand later. But now simply RH value you remember. Exact value of RH 109,677 centimeter inverse. But this RH value you can remember like this also, 1.09 into 10 power 5 centimeter inverse, like this. So approximately, so 1.1 into 10 power 5 centimeter inverse. This is all or. For solving numericals, RH value better to have one simplified one. So RH is 1.1 into 10 power 5 centimeter inverse. That you have to remember. And RH value, this 1.1 approximately I written 0.9 I written as 1.1. Understanding, sir? So 1.1 into 10 power 7 meter inverse. 1 meter is 100 centimeters, but this is ulta, centimeter inverse and meter inverse. So 10 square is extra here. So RH value I was given here and here. Why you given two RH values? Suppose asking in exam, calculate wave number in meter inverse, means this RH value, this we have to consider. Understanding? What is the formula you have? Nu bar is equals to 1 by lambda is equals to RH into 1 by n1 square minus 1 by n2 square into z square. Got it clearly? So here, what is the nu bar and what is n1 lower energy level? What is n2 higher energy level? What is z atomic number? If it is hydrogen spectrum, z is equals to 1 we will take. If it is helium spectrum, we will take Z value 2 here. If it is lithium spectrum, Z value 3 here we will take. And RH value is fixed. After 100 years also RH value is this only. Okay. So this is a constant value we have to remember. So for solving numericals, either this or this we have to use. Suppose, remember this formula better, I'll tell you. Suppose they said like this. In hydrogen spectrum, if electron jumps from fifth level to ground state in Balmer series, then what is wave number? If they ask, we can calculate or not. In hydrogen spectrum, they said. So example I will give you. So Balmer what observed as electron coming from higher level to second level, no. In what region? Visible region, no. So like that, calculate wave number means we have to use that formula or not. So I will give that example. So in Balmer series of hydrogen spectrum, if electron jumps from fifth level to ground level, then what is wave number is, this is the question. asking wave number. And they said what? Balmer series of what spectrum? Hydrogen spectrum. Electron jumping from fifth level to ground level. So in Balmer series. So what is the ground level? 2. How I came to know? Just now only I said. He only said for us. I was observed some spectral line series, invisible region, electron jumping from higher level to second level, that is L shell. He said. Why those only? Why not for first shell? Means he can he was observed those only. We can see those only actually, invisible region, as electrons jumping from higher level to second level. Getting what I am saying? So these all are very important. So here in Balmer N1 is 2. So electron coming from what level? N2. N2 is 5. N1 is 2. N2 is 5. And what spectrum this is? Hydrogen spectrum. So for hydrogen spectrum, what is Z value? 1. Because electrons belongs to which atom? Hydrogen atom. Hydrogen atomic number is what? 1. Then over numerical, RH value you know, now only I was given. RH is 1.1 into 10 power 5 centimeter inverse. Understanding sir? Actually RH value 109 677 1 2 3 4 5 zeros. Correct? So 1.09 something into 10 power 5 I can write or not? Getting? So these are the things here. Okay, approximately we can take. So 1.1 into 10 power 5. Now you have formula asking wave number. What asking? Wave number asking. Nu bar asking. So nu bar formula RH into 1 by N1 square minus 1 by N2 square into Z square. What is RH? 109. No, don't take that one. It takes more time to simplify. So 1.1 into 10 power 5. Suppose wave number given in centimeter inverse in options. Okay, in options if you have wave number in centimeter inverse 1.1 into 10 power 5. In options if you have wave number in meter inverse then 1.1 into 10 power 7 you will take. That's it. That is only the difference. Got it? So 1.1 into 10 power 5 and 1 by n1 square means what is n1? 2 square minus 1 by 5 square into 1 square. That's it. Over non-numerical. Can you simplify now? Tell me. So this in Balmer series means n1 is 2. How I came to know 2 n1? Balmer series. Okay. How I came to know n2 value higher energy level. n1 is lower energy level, n2 is higher energy level. Okay. If you confuse also, answer will come in negative. So wave number won't come in negative no. So sir, here 1 by 5 square I substituted, 1 by 2 square I substituted. So here 2 square means 4. 4 minus 25. Oh my god. 5 square no. Negative answer will come. Wave number is positive. So you won't get confused. So N1 is lower energy level, N2 is higher energy level. Got it? So our simplification over now. So mu bar is equals to now 1.1 into 10 power 5 and it is 1 by 4 minus 1 by 25 into 1. 1 by 4 minus 1 by 25. 25 minus 4. 21. 21 by 25. That's it. Into 1.1 into 10 power 5. Can you simplify this? Okay. So this is about the Balmer series. What given wave number, how to calculate given. Written all these things, have a screenshot and write down. Or put pause the video and write down all this. Okay. So Balmer series we discussed and how to calculate wave number or wavelength. Okay. We calculated. And one more thing sir, in the same numerical, nu bar you have. What is that? 1.1 into 10 power 5 into 21 by 25 you have, right? This one. Correct? 25 minus 21. 25 minus 4 by 25. If asking wavelength, so 1 by lambda. 1 by lambda is equals to 1.1 into 10 power 5 into 21 by 25. So it will be ulta. You will get wavelength lambda means it's 1 by, correct? So 1 by, so 1.1 into 10 power 5 into 21 by 25. Correct no sir? 1 by lambda. It's nu bar no? Nu bar is equals to 1 by lambda. Okay. So 1 by lambda is equals to this much. Lambda means ulta. U bar is equals to 1 by lambda or not? So lambda is asking 1 by 1.1 into 10 power 5 into 21 by 25. So you will have lambda is like this. So 25 by 1.1 into 21 into 10 power 5. So lambda is this one, 25 by 25 into 10 power minus 5 by 1.1 into 21. If you simplify this, lambda you will get. Okay. So how to get lambda also we have now. Clarity you have, sir, everyone? 1 by lambda is equal to this much only because nu bar is reciprocal to wavelength. So in this way you can understand how to calculate wave number of a spectral line or wavelength of a spectral line. So later on, one more scientist, that is Lyman series, he observed the spectral line series as electron coming from higher level to ground level, that is n is equals to 1 he observed. But in UV radiation here, in UV region he observed. In UV region he observed series of spectral line. In UV region that Lyman observed series of spectral lines as forming from higher level to n is equals to 1 level. N is equals to 1 level means what shell? K shell. So what is the ground state for Lyman? So some other scientists have a doubt actually. Why those spectral lines is forming in a visible region only? Why electron jumping from higher level to second level only? Then they started some experiment. He observed some series of spectral lines, means he did the same experiment in UV region, and he also observed that as electron jumping from higher level to first level actually. Who observed? Mr. Lyman was observed. So therefore for Lyman series, what is n1 value? n1 is 1, but n2 is 2, 3, 4, 5 and so on like this. Lyman was observed in what region? UV region he observed. What Lyman observed? He had a doubt actually. Why spectral lines are forming in visible region only? Why excited electron jumping from higher level to second level only? Why not to first level? Then he came to know, yes, that will form, those spectral lines will form, but not in visible region. In UV region it will happen. So what observed Lyman? As electron jumping from higher level to first level. So first Lyman, next Balmer. Actually first observed Balmer and next Lyman, Balmer, Passion and bracket and Fund. These all scientists was observed different spectral line series in different region. So Lyman observed the spectral line series in UV region. Balmer observed a series of spectral lines in visible region. Okay, and Passion was observed in near infrared region. He also observed Passion. And later on, Brackett also observed a series of spectral lines in middle infrared. So infrared regions are three I was given in previous: near, middle and far. So these all scientists was observed some series of spectral lines. Able to see what I written here? First Lyman, Balmer, Passion, like passion bike, passion, bracket, fund, P fund, and one more scientist is there, Humphrey. It's not necessary for us. Humphrey means is also far infrared starting, P fund, Humphrey last. Okay, so these all are very very important for us, and try to remember, not try to, you should remember. So what Lyman series? Lyman series means as electron jumps from higher level to first level actually. So next all series of spectral lines I will give you here. Okay, so electron is jumping from higher level to second level, Balmer, higher level to first level, Lyman. Okay, so what are the series of spectral lines? All type of series of spectral lines I will write one by one here. First what series of spectral line? Lyman series, right? Second one, what I told you, Balmer. Okay, and third one is what? Passion series, and fourth one is what? Passion bracket series, and fifth one fund series. Okay, this all observed as this first Balmer observed as electron coming from higher level to second level. This one n1 is equals to 1. So he observed as electron coming from higher level to first level he observed. So what is the n1 value for Balmer? Means as electron coming from higher level to first level he observed. So what are the higher level? Means greater than 2. That means 2, 3, 4 and so on up to infinity actually. Balmer was observed as electron coming from higher energy level to second level. That means N2 value is 3, 4, 5 and so on up to infinity actually. So understanding everyone? So these all scientists was observed a series of spectral lines in different regions. What Lyman observed? As electron jumping from higher level to first level. First level means what is the meaning? K shell. Okay. Second level means what is the meaning? L shell. As electron jumping from third level to second level he observed. Then what Passion observed, as electron jumping from higher level to third level he observed. So fourth level observed by bracket. This fund observed as electron jumping from higher level to fifth level actually. So these are very very important. So what is the N2 value for Passion series? So very important. Higher value for solving numericals they will say, but lower level you should know. If they said Passion series, what is the lower level? N1 is 3. Okay, LBP BP. L BP BP. Okay, so Lyman, Balmer, Passion, bracket, fund. Okay, so what is N2 value for Passion series? It's a 4, 5, 6 and so on up to infinity. What bracket was observed as electron jumping from higher level to fourth level? N2 is 5, 6, 7. Understanding? If ground level is 4 and the higher level is greater than 4, 5, 6 and 7 up to what? Infinity. Infinity, why you are saying sir means some electrons will jump to very much high energy level. We cannot see those. For those, we assume the higher energy level is infinity. Okay. So for fund series, what is M2 value? Is M1 is 5 for fund series. So 6, 7, 8 and so on up to infinity. How to remember this? L, B, P, B, P. Lyman, Balmer. First observed Balmer, no? So this B means what you can say. So P means passion, bike, passion. So again bracket fund. Okay. So now you are having some ads, no? Fund, mutual funds. Those. Okay. Lyman, Balmer, passion, bracket, fund like this. One more scientist was observed, that also I will write, that is Humphreys. Okay, so N1 is 6 and N2 is 7, 8, 9 and so on up to. This is not there in NCERT, so they won't ask in NEET exam. Okay, so simply all these things you remember. Lyman observed in what region? UV region. Balmer observed in what region? Visible region. Paschen observed in what region? Paschen, near infrared. And Brackett observed in what region? Middle infrared. Okay, mid infrared. And Fund observed in what? Far infrared. He also observed in far infrared, but far infrared range is more. Far infrared starting was observed by Fund, far infrared last ending was observed by Humphrey. This is not considerable, up to 5 are considerable for us. Okay, so what is the wave number formula? Can you guess now? Wave number formula for this? For Lyman series, what is the wave number formula? Tell me. Wave number, nu bar is equals to RH into 1 by 1 square minus 1 by N2 square into Z square. Can I use directly this formula for Lyman series? Any numerical given in Lyman series, electron falling from higher energy level to ground level in Lyman series means, okay, Lyman series N1 fix, N1 is 1. Understood? Okay, Lyman series, Giris are told already. Okay, electron jumping from higher level to first level, Lyman series. Okay, electron coming from 7th level to ground level in Lyman series means 7th level. Okay, 7 square, 1 by 7 square. Ground level in Lyman series. Okay, 1 by 1 square. You can use that formula to calculate wave number in Lyman series. Okay, for a particular Balmer series spectral line, if they are asking wave number, I was given already. Wave number nu bar is equals to RH into 1 by 2 square minus 1 by N2 square. N2 we cannot say. N2 can be anything for a particular Balmer series or any series. Anything means for Balmer series greater than 2. For Paschen series N2 value greater than 3 up to infinity, like that. Understanding? That's why I am not substituting N2 value here. And one more thing, why I am not substituting this Z value, that also spectrum they have to mention in numerical. If they was not mentioned what atom spectrum, so you can consider as hydrogen spectrum. Understanding? Maximum 99.9999% what spectrum they will mention, like hydrogen spectrum, helium spectrum, like that. And here same nu bar formula. Can you write? Nu bar is RH into 1 by 3 square minus 1 by N2 square into Z square. Then here nu bar is RH into 1 by 4 square minus 1 by N2 square into Z square, like that. So following everyone, bracket series. Okay, nu bar here, so RH into 1 by 5 square minus 1 by N2 square into Z square, like that. If you want, you can write for this also. Humphrey means it's a different no Humphrey. So nu bar is RH into 1 by 6 square minus 1 by N2 square into Z square. But RH value is fixed. If they ask in centimeter inverse, RH value 1.1 into 10.5. So final conclusion I will give you. Balmer was observed first. He taken hydrogen gas in a discharge tube and he was dissociated by sending high voltage current. Hydrogen atoms was formed and they split into hydrogen atoms and then hydrogen ions and electrons. Those electrons absorbed energy, so they will go to higher energy level. While coming from higher energy level to ground level, they are forming some spectral lines. Balmer was observed as electron jumping from higher energy level to second level in a hydrogen atom. Every atom, hydrogen has one electron, but cells are same. K shell, L shell, M shell, N shell, like that and so on. So he observed in visible region as electron coming from higher level to second level. Second level means L shell. So Lyman observed in UV region as electron coming from higher energy level to first level he observed. Higher energy level to second level he observed. Higher energy level to third level he observed passion. Fifth means higher energy, fifth, sixth, seventh to up to infinity to fourth level he observed. So this all series of spectral lines was observed in different regions, and you have all these formulas. This is hydrogen spectrum. So hydrogen spectrum you have. Now I will give complete hydrogen spectrum at one place. Okay, so we have some series of spectral lines, no, like 6: Lyman, Balmer, Passion, Brackett, Fund, Humphrey. All those series of spectral lines in the increasing order of their wavelengths, like that only I will arrange. Okay, so hydrogen spectrum completely you will have at one particular place now, because UV region more frequency, next visible, next infrared. So in increasing order of wavelength or decreasing order of frequency, total hydrogen spectrum I will write now here. So these are the energy levels. In previous I was given like this, what K, L, M like that. So those I written now like this, straight. These are the red color lines are there, no, energy levels. This one N1 is 1 actually, N1, it means N value simply. Okay, this is first shell. Okay, and this is 2, second level. N is equals to 3, N is equals to 4, N is equals to 5, N is equal to 6, N is equals to 7, N is equal to 8, N is equal to 9. Just look at these ones. These are the energy levels around the nucleus actually. So excited electron will be here, suppose at 9, and up to infinity. Last line can be infinity. Okay, we cannot say. I was written only 9 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is what K shell line. Correct? 1. And this is L shell and M shell and so on like this. N shell and so on like this. N, O, P, Q, R, S like that. Understand? So Lyman was observed what? As electron coming from higher level to first level. Okay. So how you have to draw? So electron coming from 9th to 1. Infinity to 1 I can write, but infinity means I cannot draw those names. I don't have a place. Up to 9 I written. You can draw if you have interest. You can draw up to 1000 lines, not a problem. But it's a waste of time. Electron coming from where in numerical definitely they will give. So now I consider 9 lines. So what is Lyman series? Electron coming from higher level to ground level. Excuse me. So as electron coming from 9 to 1 and 8 to 1, Lyman series, and 7 to 1 electron coming, and 6 to 1, okay, and 5 to 1, and electron coming from 4 to 1, electron coming from third to 1, and electron coming from second to 1. This all comes under what series now? Lyman series now. Lyman series observed in what region? UV region. So what actually straight you have to draw? As electron jumping from electron jumping from higher level to first level. See, don't draw like that. 9 to 1, 9 to 2, 9 to 3. Don't draw like that. Okay, Lyman series means all these lines must end in first level. That is Lyman series. So as electron jumping from higher level to first level means 9 to 1, 8 to 1, 7 to 1 and 6 to 1, everyone like that. 5 to 1, 4 to 1, 2 to 1, 3 to 1. All these series of spectral line comes under Lyman series. And what are the Balmer series spectral lines now? Balmer series, higher to second. So 9 to second, this 8 to second, 7 to second, and 6 to second, and 5th to second, and 4th energy level to second, and third to second. This is what series of spectral line? Balmer series observed in visible region. So this is Lyman series, Balmer series. You have to draw this total hydrogen spectrum belongs to all series of spectral lines, and you have to send in our group everyone. Okay. So this is the Lyman series, Balmer series. Next, what's Passion? Lyman, Balmer, Passion series. So Passion series means higher level to third level, no? So here you have, and higher to third means 9 to third, and 8 to third, 7 to third, and 6 to third, 5th to third, and this one 4th to third. What series this is? Passion series. What series? Passion series. Observed in what? Near infrared. Passion series means this black, this red color Balmer, this one Lyman. Understood? Next, Passion bracket. Bracket means higher to 4. Higher to 4 na Passion means Lyman, Balmer, Passion. Sorry, bracket. Bracket means higher to 4 or not? Bracket. Higher to 4 means here to 4, here to 4, here to 4. Oh shit. Ah yes. And here to 4. These all spectral line comes under. These are Lyman, Balmer, Passion, now bracket. And fund series means as electron coming from higher level to fifth level. 9 to 5, 8 to 5, 7 to 5, 6 to 5. These series of spectral lines are called fund, P fund. Fund series, actually P we will write that silent. Fund, no need to say. P fund. Fund series, his name actually. Okay. So these scientists was observed and total series of spectral lines. See, in this way you will have increasing order of wavelength or decreasing order of frequency. So hydrogen spectrum. Spectrum means increasing order of different radiations. Radiation means spectral lines only here. In increasing order of wavelength or decreasing order of frequency. See, Lyman series understood now? Higher level. Infinity to 1 you can write, not a problem. If you want 10 you can write, 11 you can write, 12 you can write. Up to 20 lines you can write, not a problem. Okay, this is total hydrogen spectrum representation. Lyman series, Balmer, Passion, bracket, fund. If you want Humphrey also you can write higher to 6th level. Got it? So write down this hydrogen spectrum and you have to draw this properly and you have to send in our WhatsApp group. Okay, thank you. These are very, very important. Listen, hydrogen spectrum numerical pakka they'll ask you in exam. Okay, sir.